All right, everybody. Hello, welcome, good day. I hope you've had some time to, let's see if I can get this right. I hope you've had time to practice. I can't get this. Practice and discuss. I can't do this. Demonstrate, get some audio visual in. I'm going to do very little lecturing. Very little lecturing because that's in red. That's not the best way to learn. We're going to do some more work today, but it's based on what we've already learned. I'm just going to share a couple supplemental ideas, just a couple little thoughts that you probably already know, but if you don't, I'll just add to where you're at, and then we'll do some work. So we won't spend much time together today, but just a little bit. I think I'll start with this. Let's start here. Do you know what 5Q plus 5Q is? Yes, yes, you're welcome. You're welcome. If you said thank you, then thank you for saying thank you, and I'll say you're welcome. So anyway, just hopefully something to get you smiling just a little bit as we talk about factoring expressions. We've already talked about factoring expressions. We have an expression and we try to find what can we pull out of both of those numbers by division. What comes out with the biggest number we can get out of both of those, and it's 3. And when you divide by 3, there's just a 1. And when you divide by 3, there's just a 6. I purposely tried to stay away from some of the formal language. I just wanted to kind of show you through division what we're doing. But let's go ahead and now use the formal language. The GCF, you've talked about this before. It's the greatest common factor. What is the biggest number that goes into, that's the factor, that goes into all the numbers? The greatest common factor. Greatest number that goes into all of them is what it means. So what's the greatest common factor of 18 and 24? Well, you know it's going to be something that goes into the smallest number, and then we just start listing the factors. I showed you how to list the factors, 1, 2, 3, 18, 9, and 6, and then we're done. And then you can list the factors of 24, 1 and 24, 2 and 12, 3 and 8, 4 and 6, and we're done. And what's the biggest number in both of those lists? 6. So we did this yesterday, but what if I gave you this work? What if I gave you something like that? And I said, all right, what's the greatest common factor? Well, we'd look at the numbers first. You'd find the biggest number that goes into both of them, and you'd find 3. Another way I said it is what line in the multiplication table has both of these numbers in it? What's the biggest line? And that's 3. Then we can look at the variables, and what's the same in each of those variables? Well, they each have an x, so we can pull out that x. We can divide out that x. And then write what's left. 15 divided by 3 is 5. I've pulled out the x, I've divided by the x, so it's gone, and all that's left is a y. And then plus 12 divided by 3 is the 4, and the x is already gone, so that is my answer. That's it. So you can pull out variables as well, just like we were pulling out numbers yesterday. And finally, what if I were to give you a rectangle? Pretend this is a rectangle. Let's say that I said the area of that rectangle was 24m plus 60. That's the area. I know it looks kind of like a weird area, but what could the sides be? What could the lengths of the sides be? The area is length times width. So what could I multiply together to get this item? Well, what they're asking is just factoring this expression. So if I pulled out a 2, I'd be left with 12m plus 30. So it could be, one of the sides could be 2, and one of the sides could be 12m plus 30. So it's 2 and 12m plus 30. But what if I said I want to pull out a certain number? What if I said I want to pull out 12? I want 12 to be the length. Well, they've just given you the greatest common factor. You then simply find the width. So 12 out of that, 12 divided from that gives you 2 m's. And then 12 divided from 60 gives you 5. And there you have it. The area factored into a length times a width. So that's all. Just a couple more thoughts. That's all it is. Not much to add on to what we learned before about factoring expressions. This is really just a supplemental bit of information. Should do fine on the assignment even without knowing this, but just one way to help out. Well done. Good job. I hope you say thank you. If not, I'll say thank you for watching this in terms of I hope that it was beneficial for you. And I hope you have a great day and week and weekend and next week and on and on and on. Talk to you soon. Bye-bye.